Happy Thursday of week 1, and you're still with us. That's so awesome. So today we get to do a little bit of math, not a ton of math. The good math starts coming next week. I'm gonna ease you into the math stuff. So you can like learn vocabulary and see pretty pictures, and then we will ease into it and do some real math. Next week, you will need your fancy calculator. We do not need it today. If you want to use a calculator, you can just use a regular 10 key or whatever phone calculator, but next week you'll need this. So today we're going to finish up section 2.1. We're just going to finish up with some pie charts. Then we're going to go into 2.2 and we're going to talk about making some discrete data histograms. And we're going to put some continuous data in tables and construct continuous data histograms. We're going to do a stem and leaf plot and identify shapes of distribution. And then we're going to finish up by going over lab 1. So when I do the labs with you, I treat it as if you've never used Excel before. I try to walk you through every teeny tiny little step because many people come in, have not taken CS 120 yet, or maybe it's been forever since you've used Excel. So I try to make sure that I walk you through every teeny tiny little step. And if I skip over something you think you need, ask me. I will go back and show you. I love Excel. I am kind of a spreadsheet junkie. I love putting everything in spreadsheets. I love making things pretty and organized and all of that. I mean, I guess it's just a math person thing, but I like to impart that knowledge of spreadsheets. It's super useful and helpful. So make sure you ask those questions. So that's tonight, and I'm excited to get going. Oh, and if you haven't done it already, I think most of you have, most if not all of you have. Make sure you do that that assignment that's due today. It's a pretty quick one, but it's the attendance. That is your attendance for the week, is the yeah, your attendance for, and you, so you're not dropped from the class. You need to make sure to get that done. Even if you just start, I mean, it's due tonight, so you don't want to use a late pass this early in the term. But if you needed to use a late pass, that's fine, but at least get it started. At least if you do like one question or put the late pass on there or whatever, I can take attendance. But I don't want anybody to get dropped from the class that doesn't want to get dropped from the class. So there you go. Now I'm going to move on. Okay, so we're starting with discrete data. This discrete data, well, we're putting it into, this is in millions. So this would be like the never married in 1990 is 40.4 millions. So technically it's still discrete, but it's because it's huge numbers, it doesn't look like it's discrete. It looks like it's continuous, but technically it's discrete. So, but we're going to compare two data sets here. We're going to create a side-by-side bar graph and hope my cat quits attacking my arm. So we have the marital status from 1990 and 2006. So this is, it's not raw data, but it's not like relative frequency. It's really hard to compare them because our populations aren't the same size, but we still can kind of get a little idea. So what we're going to do is we're going to create a side-by-side relative frequency bar graph so that this can be more meaningful. Because right here, I can't see percents. Looks like 2006, so many more are married and so many more are also never married. So by numbers, yes, but let's take a look at what percents tell us. So once again, remember the way that we calculate relative frequency is we take that data set, so the frequency of one of the things. So like, for example, I would take the 40.4 and divide it by however total number we have. Now I haven't added it up. I'm not going to add it up, but I would take the 40.4, then divide it by however many people, 40.4 million, divided by however many millions were in the survey or were in the study. And then that would give me my relative frequency. So it tells me the proportion of the entire population that's never married. So here's my relative frequency table. So once again, I put relative frequency over on the side here, and I'm creating a bar graph. So now we're at percents or proportions. So you can see if you look here that we're about 25% in 2006 were never married, and about maybe 22% in 1990 were never married. And so you can kind of see our proportions here. All I'm doing is taking the proportion and converting it to a percent. So like right here, this is probably about 61% to about 59%. And you can kind of compare and see where we were. So if we are looking at you can see that the majority of the people in 1990 were married, and that it is a larger percent than in 2006. 2006, we have more divorcees than we did in 2000, than we do in 1990. So the trend looks like we have, or sorry, not divorced, never married, also divorced. Looks like the trend is either never married or divorced in 2006 rather than married. Any questions about the side-by-side bar graph? So we do this when we have two different populations that we are comparing. So our populations would be adults in 1990, United States adults in 1990, and United States adults in 2006. I think that's what it is. Let's see. Do we have that? US residents 18 years and older. Yeah, that's basically what I said. Okay. So let's talk about a pie chart. I am not going to require you to hand draw a pie chart, though it's kind of fun if you have a protractor. And I am weird thinking these types of things are fun. But if you have a protractor, it's not too bad. But it's a circle. We divide it into sectors. Every sector is a category of data, and the size of the sector is proportional to how frequently that category occurs. So you've seen thousands of pie charts in your life. It's very, very familiar. It's not anything new. Let me show you. Okay, so we're going to take just the 2006 data of the never married, the marital status of US residents 18 and older, and we're going to put it in a pie chart. So there we go. Now, when I see pie charts, I like it when the percents are on there because it's not quite as meaningful if it doesn't tell you what percent are in each category. So this is nice and meaningful because I can see 50%, 58% are married. I can see 6% are widowed. So if we did this by hand, you would calculate the degrees of each sector. So I would take 58% of 360 degrees and figure out what that number is. And I would use a protractor to measure what the angle is. And then I would draw it in. So thankfully Excel does this for us, and it's going to do things much prettier than I'm going to do them. But I'm never going to require you to do it by hand. But in real life, if you decide you want to make one by hand and not use Excel, this tells you how to do it right here. But I don't recommend it for the average person that doesn't just love making big circles with I like to use my compass and make a circle and then use my protractor, but I'm a nerd. That's what we do. All right, moving on. Okay, so we have some discrete data here. We're going to construct a frequency distribution and a relative frequency distribution. This is what we were doing on Tuesday, but we're going to take it further and we're going to make histograms out of them. We already did bar graphs. Histograms are very similar to bar graphs. They just have a couple of little differences. So once again, this is raw data. I haven't done anything with it yet. I haven't cooked it yet. I haven't done any kind of organizing. It's just random sample. So just as I'm getting the info, I'm just typing that number in there. So this is 50 random sample of households, and we want to know how many cars each household has. It says number of available cars, so I'm assuming this is cars that run. Because my daughter and my son-in-law, if you were just saying all cars, there'd be like 5 or 6, but cars that run, there'd probably be 2. He's the typical car guy. You know, they have lots of not running cars. It's pretty common. Okay, so once again, I tallied them up. You don't have to show the tallies. I tallied them up. I have 4 people with 0 cars, 13 with 1, et cetera, et cetera. To get my relative frequency, I took the number in that category, so 4 divided by 50, because there's 50 total, and I got 0.08, 13 divided by 50, 0.26, 22 divided by 50, et cetera, et cetera. That gave us our relative frequency. So I can see the proportion of my sample that has that characteristic. Questions so far? Are we doing okay? All right. I know we'd all rather be out in this gorgeous weather. Isn't it gorgeous out there? It's so pretty outside right now, at least where I am. It was really
Got a
nice.
question.
Yes.
Is the histogram always relative frequency?
No, it is not. The histogram can be just frequency, but relative frequency is usually more meaningful. So, but it can be frequency or relative frequency. It doesn't matter.
Thank you.
That was a good question. Thank you. All right. So histograms. The histogram's similar to a bar graph, but there's a couple of differences. So the histogram is rectangles for each class or category. That's the same as a bar graph. The height of each the height of each rectangle is the frequency or the relative frequency. That's the same as a bar graph. This is the difference right here. The width of each rectangle, yes, they're the same. The rectangles touch each other. They bump right up against each other. Part of the reason for this is most of the time we use histograms for continuous data. And so there's not going to be big gaps between it. We need it to look continuous. So just one of the characteristics of a histogram is the bars touch. That's the biggest difference between a histogram and a bar graph is just that the bars touch. Now, when you do it in Excel, there's going to be a slight space between them, and you can make it so there's no space between them, but you'll see it's just kind of a line that separates. But this is the biggest difference right here. Your rectangles need to touch each other, and I'm going to show you how to do that in Excel. I'm not going to ask you to draw a histogram on your own on paper. Okay, once again, here's the data that we were using. Here is my histogram. So when we are using discrete data, for a histogram, the value of the that represents that column, it's just going to be in the middle, right underneath each one. So my one cars, it's smack dab in the middle underneath the bar that goes with it, the rectangle that goes with it. So this is generally what we do with discrete. It's going to look like this. Make sure that your bottom of your this starts at 0 down here, and then you go up by even increments. Excel is going to do all of that for you. You need to have a title. You need to have the title. We need to have the axis titles. And then you're going to have your these are called bins. They're called categories. They call them classes. There's several different names for them. So here we're just gonna, I guess they're categories because I have the category of 2 cars in the household. There were 22 of them. The relative frequency is gonna look basically identical. So there it is, but it just has relative frequency instead of frequency. Hours that we do in our lab are gonna be frequency histograms. And I guess technically if you wanted to make it relative frequency, no one's gonna get mad at you, but it's gonna be more work, so just don't. Questions so far? Alrighty. So I kind of already mentioned this. Classes are categories in which the data are grouped. We also call this bins. Excel calls them bins. So when we're using continuous data, we created intervals of numbers. We're going to create ranges of numbers that fall in those categories or classes. And there's very specific ways that we do this. There's the way that our textbook tells us to do it, and there's the way that I do it that I like better, and you can decide what you want to do, but I like mine better. So if I have a lot of different numbers, like and it could be, if it could be discrete, but I might have like a really wide range of numbers. And so I would want to put them together, or if we're continuous, we would do it. So let me show you what that looks like. Okay, so this one is age. So the data represents the number of persons ages 25 to 65 who are currently work disabled. So this is discrete, but actually it's continuous. It's ages. Sorry, I just lied to you. It is ages. So it is continuous because even though we're using whole numbers, but it still is. So my categories are 10 wide because it goes from 25 to 34, 35 to 44. Your classes, your widths always need to be the same. Always the same. I need to move it over. Let me see, move it over a little bit. The same width. So my classes are always going to be the same width. The lower class limit is the smallest in each category. That's the lower class limit of each. The lower class limit of each of my bins or my classes is the lowest value in that class. The upper class limit is the largest value in that class. I know this is like real stretch, right? So our lower class limit is the lowest value in that class. Upper class limit is the highest in that class. The way that we can see what our class width is you subtract the lower class limits from each other. So I could do 35 minus 20, 35 minus 25, and I can see my class width is 10. It shows me right here. So in this case, my class width is 10. So you just take two that are next to each other. It doesn't matter which ones. I could take those two. Just has to be two that are next to each other. You could take those two. I wouldn't take 25 and 55. You just take two that are next to each other. Okay. So here, this is our next set of data. It represents the time between eruptions in seconds for a random sample of 45 eruptions of Old Faithful Geyser in Wyoming. We're going to construct a frequency and relative frequency distribution of the data. All right. So I put these in order. No, I didn't. On a different screen, I have them in order. It's like I thought I put them in order from smallest to largest. I didn't. But these are all just in minutes. It's definitely continuous data. There's a whole lot of them. So what I need to do is I need to create classes. So there's kind of a trick that we do when we're creating these is we generally like our numbers to be pretty. They don't have to be. You could start at 672 as your lowest lower class limit, or I would do 670. I find a pretty number. I think that our text calls it a convenient number. I look for a pretty number right below my lowest value. I'm going to choose 670. I want my lowest class limit to be 670. And then I'm going to make the class width 10. So it'll go 670 to 679, then 680 to 689, 690 to 699, etc., all the way down until I get to 739 so that everything is included. I'll show you what that's going to look like. And then I'm going to count them and put them in there. So here's what my classes look like. Every data value is included because my lowest one is 672. My highest one is 738. And so they all fit in there. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 bins. Okay. So here's my frequency table, actually my frequency / relative frequency table. This looks nice. There's one that has a 0. So I'm gonna give you a little secret here. Statisticians try to make things aesthetically pleasing. They want them to look nice. If they can make it look nice, they're going to make it look nice. It's just what they do. So this isn't going to be too bad. We have a decent number of bins. We do have one empty bin, Sometimes that can't be helped. But I want to try to avoid having like 5 empty bins or like 3 empty bins next to each other because it just looks ugly when you create a histogram. But 1 empty bin is not super bad, and so I'm happy with this. We're going to change the class width. So now I have a class width of 5. Take a look here. I have 3 empty bins all next to each other. That's just ugly. We don't like that. So generally, I try to keep it between, we usually say between 5 to 12, 5 to 12 bins in our histogram. We could possibly go up to 20, but that's in extreme situations. But 5 to 12 is where we like to keep it. It's just a rule of thumb. Now, I would like you when you do your lab to not go below 5. Now, if you and I don't want you to have like 50. I want it to be try to keep it between 5 and 12. Now I'll talk about that again when we do the lab. When you're creating your histogram, try to keep it between 5 and 12. Now, if you had 13, I'm probably not going to get mad at you. But if you had 25, I might take some points off, if that makes sense. So I'm going to say, well, stay between 5 and 12 bins. Because once again, we want to make our data display meaningful. Fewer than 5 and greater than 12, it's not as meaningful. And so we want it to be meaningful and we want it to be aesthetically pleasing. So if I was creating a histogram, I would go with this one because I only have 1 empty bin and I do have between 5 and 12 and it's going to look really nice. This one would have a big empty space and I don't like that. Questions so far? Okay. All right. So I already kind of said this part. When you choose your lower class limit, when we're doing this, look at your smallest observation and find a number, convenient number, pretty number, pretty number. I like the word pretty better. Find a pretty number slightly lower than your smallest observation. And just, once again, we like things that are aesthetically pleasing. And I'm going to show you a way to trick Excel when we get there so that you have the most aesthetically pleasing numbers. You don't have to do it. It's just what I do because I like things pretty. Like my annoying cat. She's pretty, but she's annoying. She's lucky she's pretty. Okay. So I'm going to tell you before I teach you this piece, I don't do this. I don't like this. This is the way the textbook does it. And I'll tell you what I do after I tell you what the textbook does. So when you are figuring out your class width and figuring out how to set up your bins, what the textbook says to do is to choose the number of classes you want. So pick a number. They say 5 to 20. I like 5 to 12. That's why I said I'm not going to throw a big fit if you go a little bit over 12. But 5 to 12 is best. But so what they say is they say choose your number of classes. Then you take your largest data value, you subtract your smallest data value, and divide it by the number of classes you want. I'm going to show you exactly why I don't like this. Because let's say my lowest data value, these are random numbers. Let's say my largest data value is 238. My smallest data value is 116. And let's say that I decided I wanted 7 classes. This is just a number that I chose. 238 minus 116 divided by 7. This would make my class width 17.43. Tell me that isn't ugly. So I like to have pretty numbers. What I do when I do this, instead of determining how many bins I want, I determine how wide I want my bins. So I will say, I'm going to try a width of 10, and then I will get this right here. Like, okay, I like that. Maybe I want more to try more bins. Okay, well, let's see what happens when I have bins of 5 width. Then I would look at this and be like, nope, I don't like that. I'm going to stick with 10. So I usually just choose a width of bins I want first, and then take a look at it and see how it looks, and then make adjustments from there. That way I can end up with prettier numbers here. I want prettier numbers there rather than having these weird decimals. If you want to do this, absolutely go for it. It's just not my favorite. Oh, sorry, this realize there's a little internet delay. If you want to do this, go for it, but it's just not my favorite. Questions so far? All right. Okay. I think that I am. Now I'm going to show you the histogram that I get from these Roth IRAs is a um, default histogram from Excel, and I kind of want to show you what Excel gives you. That's why I did this one. This one came off of page 79 in your textbook. This is a 5-year rate of return for a simple random sample of 4 mutual funds. So I'm going to create a frequency distribution, and then I'm going to do a well, it's upside down. Then I'm going to do a histogram. So I decided to make my bin width 1%. So notice I have my bin width 1%. I do have 2 empty ones right here. I'm not super happy with that, but I noticed when I did 2%, and I don't have that for you. I didn't really like the 2%. So I kind of left those there even though I don't really like it. Right, here's an Excel histogram. I still do not really like this, and I kind of wish that I did another one here with 2%. But see, look, see, Excel just chooses the lowest data value. I personally would choose 8 to 8.99 or 8 to 9.99. Excel just grabs your lowest value, and it'll give you whatever random bin width it decides to do. I will show you how to fix those and make them pretty. The things that I don't have on here, this should say frequency. And then this should say rates in percents. I could do it like this. I don't think I have a good histogram, but I kind of want to show you. If I was drawing one by hand, I want to kind of show you. Let me see. Give me a second. I'm going to see if there's one in the homework that is a good one. Because this is important. Where are we? We are in spring 2025. So this would be the 2.2 homework. Let me see what I could find. There's any, I don't know if there's any continuous ones in here at all. Yep, there is. Okay. So notice this one right here. This is a continuous histogram. I want to show you what these numbers mean. So this is the normal way you would see a histogram, not in Excel. This is a normal way you'd see a histogram. This number right here, 220, is the lowest value in this bin right here. This number 240 is the lowest value in this bin right here. So what it gives you is the lowest value in the next bin. So 260 is the lowest value in this bin. So we don't usually represent both the lowest and the highest. We just see the lowest value of the bin to the right of it. This one does the same thing. Well, I thought that was the same way. I guess not. Okay, this is the best one. Then 300 is the lowest value in this bin. So this one goes from 300 to 319, if that makes sense. This is the normal way a histogram looks. In Excel, it's going to look a little bit different because Excel does its own thing. It makes its own rules. Questions, comments, queries, concerns?
Yeah, so if you'd artificially created the number 220 as being a number lower than your actual value, would it not be filled in blue all the way down to 220? Like if your first value was actually 223,
It's
would there be? gap.
Where we care more about what fits in the ranges of values rather than the actual lowest value. I don't care if the actual lowest value is 220 or 223. What I care about is how many I have between 220 and 240.
Okay.
So I don't care what the actual value is. I care about how many are in each
There's
section.
just four in that thing, so it doesn't matter that it, okay.
Yeah. So
Okay,
that's choosing the pretty numbers doesn't really affect anything. It just makes it look better.
gotcha.
Yeah. That was a great question. Thank you. All right. Any other questions? Okay. So once again, I'm going to give you my little disclaimer before I teach you about stem and leaf plots. Every time there's something I don't like that the curriculum does, I have to give you my disclaimer. We have to teach stem and leaf plots. There might be a question or two in your homework about them. I will not test you on them. I have not yet found any good use for a stem and leaf plot, anything that makes it better than any other kind of plot. If anybody can find a use of stem and leaf plot that makes it better than any other representation of data, I would love to know about it. These are my least favorite ways to represent data, but I have to teach it. So I'm going to teach it. You might have a question or two in the homework. You will not be tested on them. So there's my little disclaimer. So what the stem and leaf plot does is it takes the digits on the left, makes them the stem, and then the last digit becomes the leaf. So if I have the data value 147, and I have this vertical line here, 1, 4 would be here as my stem, then 7 is over here as the leaf. And I'm going to create a couple of stem and leaf plots to kind of show you what they look like and how to create them. I think in the homework, they just make you read one that's already made. They're not my favorite, but it is what it is. We teach them and we nod our head and smile. Okay. So we're going to look at the geyser eruption data. The currently we don't have, this one doesn't have decimals. When we do decimals, the stem is going to be the integer portion and the leaf is going to be the decimal. And I'm going to do one of those as well. And give you a moment and to write it down if you're going to write it down. But you will never be tested on it. Okay. All right. Here's the geyser data. I put it all in order, smallest to largest, because it's going to help me organize it a little bit better. A lot of times we just have raw data, and I'm going to show you what that looks like when we throw together a stem and leaf plot. Okay, here's my stem. My stem has the first two digits. So the 670, 680, 690, etc. When I create a stem and leaf plot, the ones place is going to be on the right-hand side. So it's going to look like this. So I have the value 628 or 672, sorry, 672, but I also have 678. I don't have anything in the 680s, but in 690s, I have 695. I have another 695. I have three of them. Then I have a 696, 698, and two 699s. We put them from the lowest number to the highest, and we repeat them if they're repeated. So here's what I have in the 700s. I already have it written down over here, so I'm just copying it. And I'm going to tell you just a second why we have 272s. Sometimes
So
when
it's like, sorry, so it's just a way to consolidate numbers?
yes, that's really all we're doing. So I'm a way to represent every data value,
Right.
but yeah, in a smaller space. So with 720s, we had a lot of data values that were 720s. Sometimes when we do that, we'll split them. So the top one's going to be 720 to 724, and then the second one will be 725 to 729. You don't have to split these. You don't have to ever do this, but a lot of people do it. And so I'm doing it just for demonstration purposes. So this would be 720 to 724 and then 725 to 729. Whenever you make a stem and leaf plot, you need to make a key. So you grab any random data value and we're going to make a key. So I'm going to do 696. $696. So that's how you would write your key. I'll probably put the word key up here. Why not? So you take one data value and you show it like this to say, what does it represent? Questions about this? So I'm going to do the interest rates next, and I'm going to show you what happens when we kind of are all jumbled. Okay. Oh, these aren't interest rates. These are unemployment rates. So this, I don't even know what year this was. These were unemployment rates some particular year per state. So I have 50 of them. So generally when I start making a stem and leaf plot, I just write them down in the order I see them before they're organized from smallest to largest. So my first setup is all jumbled. So these are not in order. They're in the right row, but they're not in the right order. We can't leave it like this. Therefore, once I do this, then I rewrite it and put them in the right order. So then they're all nice and pretty. I still do need to have a key. And I would just say, let's say 4.3 represents 4.3%. That way I know what I'm looking at. So the tenths place, that decimal is after it's part of the leaf, and the whole number is part of the stem. Questions? Does everybody kind of see why I don't find them super useful? If you find a way, if you find any type of data that this is the best way to represent it, I don't know. I don't know what I will do, but I will be really grateful. Just post it in the forums and that can be your discussion for the week. If you find any data out there that is best represented by a stem and leaf plot, post it in the forums so that we can see that this actually does have a really great use, because I have not found one. All right. Are we all done with stem and leaf plots? We're ready to move on? I'm ready to move on. Okay. Let's put those in our rearview mirror. Okay. So we're going to talk about shape of distribution. We're almost done. We're almost done with this and we can get on to the lab. So the shape of the distribution, this is going to carry with us for quite a while. This is something that we bring with us through the rest of the term. Some of the other stuff, you kind of learn it now, and then you might pick it up again when you do your final project, but we don't use it a whole lot. The shape of our distribution, we use it a lot. This is going to keep coming up, just letting you know. So a uniform distribution, it basically looks like a rectangle. All of the frequency of all of my data is pretty evenly spread out. Oh, it's not always like exactly flat. I might have like one that's slightly more. I might have something like this, and maybe this one over here is slightly down. But if it is mostly rectangular, then it's uniform. Because statisticians don't deal in absolutes. We can say something is mostly uniform or relatively uniform. If it pretty much looks like a rectangle, you can call it uniform. We also say it's symmetric, but we say that with a couple of different ones. Uniform's the best word for that. Okay, now we get to the fun ones. This one's boring. Okay, this right here, this is the one we want. This is our favorite. This is the one that we try to use for almost everything. This one is bell-shaped. We also call it normal. This one is bell-shaped. If I drew a curve over it, it makes a nice, pretty bell shape. Once again, it's not always perfect. You can say relatively bell-shaped, mostly bell-shaped, approximately bell-shaped. As statisticians, we like our adverbs. So you can just use those to your heart's content. So this one is nice and pretty and bell-shaped. It's big, it's highest right in the middle, and then it kind of goes off and has tails to both to the right and the left. Nice, pretty bell. It's symmetric, so I could draw a line right here. And if I folded it on that line, it would mostly line up on itself because it's nice, it has symmetry. So that's the bell-shaped or normal curve. Now's when we're going to get crazy. Exactly the opposite of what you would think. This is skewed right. We talk about skew by where the tail is. We have a tail off to the right, so it is skewed right. Our peak is on the left. So we have the peak on the left, and then we have this long tail on the right. The tail on the right means it's skewed right or right skewed. You can say it either way. Skewed right or right skewed. I bet you dollars to donuts you can guess what the next one is. Right there, we are skewed left or left skewed. We've got a tail over here on the left. My peak is over here on the right. So when we go by the tail is on the left. It is skewed left. All right. I'm going to quiz you. You can just keep your answers in your head if you want. You could type them in the chat if you want. But I'm going to quiz you on these shapes on the next few slides. And let's see how you do. Unless you have questions before I get there. Good. Okay, here we go. In your brain or in the chat, what is the shape of this distribution? Yay! It is. It's bell-shaped. It has this nice, pretty bell shape. I just love drawing these. So yeah, this one's bell-shaped. Okay, next one. Take a look at that one. We think. Yay, yes, skewed right. Yay, good job. It is skewed right. I forgot the S. Skewed right. Good job. The tail is on the right, therefore it's skewed right. Okay, here we go. This is boring, but it's pretty good. It's a good representation. Skewed left. Yes. We are skewed left because we have our tail, whoops, over here on the left. Good job. I bet even with before I get there, I bet you could figure out the next one. You will be seeing some uniform distributions. The funny thing is the biggest thing we do with uniform distributions is try to find a way to make them not a uniform distribution, but we will see them a little bit here and there. It's kind of funny how we work really hard. That's coming in chapter 8, where we're trying to make a uniform distribution not uniform. So, all right, good job. So that's the last of the slideshow. Before we do the lab, that's the last of the new material. All we have left to do is the lab. So before we move on to the lab, I would love questions about our material we just covered. Anyone? Okay. I'm going to put my iPad down and feel free to work along with me on the lab if you want, or just pay attention. This is still being recorded. So if you want to revisit this one rather than revisiting the, there is a video in Blackboard that's probably just as good as you're going to get from me right here on how to do the lab. So once again, remember, you only need 20 data values of each one. The lab itself says 50 on it. Let me get there. The lab itself says 50. You do not need 50. So right up there, it says 50. It's kind of a reward for either coming to the Zoom meeting or watching the video that you only need 20. I can always tell who didn't come to the Zoom or watch the video by them having 50. It's kind of fun. Doesn't matter though. If you want to do 50, go for it. You could just have fun. Sometimes we just get on a roll and you empty out a bag of M&Ms and you're like, well, there's 55 M&Ms in here. I'm going to put them all in my lab. So there you go. We're going to start with categorical. Okay. As a reminder, categorical data is generally words. It's generally words, or sometimes it's numbers that you wouldn't do math with, but most of the time it's words. It's something that describes a characteristic. So what I did is I have imaginary friends on Facebook. I would love it if your data is real, but I'm not going to know one way or the other. Just saying. So I have imaginary friends on Facebook, and I pretended that I asked them their favorite color, even though I did put my sister here. My sister's favorite color is brown, and I think that's silly. And so I put brown there. So I asked their favorite color. And so this is your raw data. So when you collect your data, I want you to just type your raw data right here. I also put the what my data represents right here. You don't have to because you're going to answer it in the questions, but I put favorite color right here. You don't necessarily have to do that. So up here, this is your population. My population was my friends on Facebook. That's my population. So whatever your population is, that's what you're going to type in here. Next says, what variable are you studying? So I am studying my friends on Facebook's favorite colors. You do not have to tell me why you're interested in the population and variable because you don't have to be interested in it. So just ignore that question, but just tell me what variable you're studying. I am studying favorite colors of my friends on Facebook. The units of data. Now, units are generally things like feet, yards, miles, things like that. You don't really have units. So you can just put NA here, put no units, put NA, put no units on categorical data. I don't care. Just put something in here representing that there's not any units. So this right here, the why are you sure your sample data is categorical? Refer to the definition of categorical data. And I would say, I know that my data is categorical because these are colors. They're not anything I can do math with. They're a characteristic of my friend's favorites, I guess. You're going to basically just use the definition. Look back at the definition of categorical and say that these are characteristics that cannot be quantified. That would work. Where did you get your data? I don't care about the second one. They explain how well your sample represents your population, especially since explain is spelled wrong. Just type in here how you got your data. If you asked friends, write you asked friends. If you went to NFL.com, type in here that you went to NFL.com. I'm going to tell you, Google is not a source. If you've taken any English classes or writing classes or anything, Google is not a source. So you can even just give me the name of the website. If you said, I went to the US Census website, that's fine. You can say, I went on Amazon and Googled, or I went on Amazon and searched for tennis shoes and took the first 20 tennis shoes and their color. I don't, however you got your data, this is where you're going to put that. Okay. So now what you're going to do down here is you're going to organize your data. So I put all of the answers that I got, every individual answer in my X values. I'll make it bigger so you can see. And then I counted them. I have 5 green. I have 7 blue. I have 7 red. I have 1 brown. I have 1 pink. Now I'm going to tell you there are fancy schmancy ways of making Excel count it for you, but we are not getting fancy in Excel this term. I am not going to, if you are an Excel aficionado, feel free to use the fancy schmancy ways of doing that. There's a count if function. You're more than welcome to do that, but just count them. Just count them and put them in there. Okay, here's how we're going to do the pie chart. You're going to highlight. So you just click on the top one here, hold down your cursor or your touchpad or your mouse or what your left click on your mouse, highlight all of them. Whoops, I'm going to do it again. Highlight all of these. I don't want an update. Stop it. Okay, I highlighted all of them. Go up to the top and click on Insert. Notice over here you have all of these lovely graphs. The recommended chart will most likely have what you want. So when I click on recommended charts, it has a nice pie graph right there. Or if you want, you can click on the little picture of the pie graph and you could choose the pie graph there. Most of the time, the recommended charts is going to have the chart you want. So I'm going to click on that and it's going to give me a pie graph. It is not done by any in any way, shape, or form. It is just super, super basic. Some things are really annoying, like take a look. My red is green, my blue is red, my green is blue. That's kind of annoying. Before I fix all of this, I'm going to play with some other things. So I'm going to change my chart title. Friends' favorite colors. Then I'm going to go up here and I'm going to choose a chart style. Look at all these styles. There's so many of them. What I want from you, I want the percents on I want you to have the percents on your graph. You can be super creative with with a whole lot of it, but I do want percents on your graph. So I'm going to choose that one because that one has percents. There's a lot of them that have percents. There's a whole lot of them. I think even here I can add a chart. I don't know if I can or not. So ignore that, but you can also change your colors. I can change them all at once, but I'm going to change them individually here in a minute. I'm going to show you how to do that. So you could do all sorts of things with it. I want you to have fun. Have fun. Play with the different things, because that's the whole point here, is for you to play with it. The requirements for your pie chart are that you have a title up here and you have percents on your pie chart. After that, go crazy. Okay, now I'm going to show you how to change the colors. I'm going to just double click on my pie chart. So there, I just did that. I double clicked on that. I want this specific one. And notice how this one has the little paint fill right here. So this blue one here is supposed to be pink. And no, it's supposed to be green. So I'm just going to change it to green. This red one here is supposed to be blue. So I'm just going to go through and just change them all. If you click on each individual slice, you can get that color right there. So that one is red. So I can just make it what it's supposed to be. This one right here, this purple one is supposed to be brown. My darn sister and her brown. She's beautiful and adorable, and I love her to pieces, but that's just a weird favorite color. There's pink. All right. So good enough. So there's mine, and it's lovely, and there we go. Any questions about the pie chart or categorical data? Okay, let's move on to continuous. So my continuous data, I went kind of crazy and I went a whole bunch of different countries in the world and I found their highest magnitude earthquake that they'd ever had. So that's what I did. So there's going to be a few things that I'm going to allow you to opt out of on your histogram. And the reason I'm doing this is because they've changed the way Excel works and it's much more histogram friendly now than it used to be. So first thing I'm going to do is I am going to highlight once again. So once again, this is raw data. I have way too many. You only need 20. I have like 100 something because I'm a weirdo like that. Okay. Before I do insert my histogram, I'm going to tell you, you do not need to do this piece right here where it says intervals here. You do not need to do that piece. You can leave that blank. For which question? Question D? Question D is you're using the definition of like continuous or categorical or discrete to describe how you know your data is continuous. So, for example, I know that my data is continuous because it can take on any value. It is not something that's countable. So that's how I know it's continuous. So go take a look at when you're doing these, take a look at the definition and then use that to determine how you know. So my population here would be countries of the world. My variable I'm studying is magnitudes of earthquakes. Usually 99 times out of 100, continuous data will have units, feet, miles, pounds, ounces, inches. Of course, I chose the only stuff that doesn't. Yep, this is the one where we're going to have 5 to 12 bars. I'm going to show you how to do that. And then once again, how did you get your data? Time. Yeah, well, time would be minutes or seconds. So yeah, depending on how you categorize it. All right. So once again, I highlighted all my data, and now I'm going to go to insert 99 times, most of the time, it'll be in your recommended charts. So it's down here. You don't want the one with the weird line on it. It's going to be this one right here. So I'm going to choose that. I'm going to put it down here. Okay. So I recommend before you do anything else with it, do your colors, pick the colors you want. Pick anything else fancy you want with it. So probably do that first before you do anything else. There's a few things that we have to do here. First thing, chart title, Earth, let me see, max earthquake magnitudes by country. Apparently I can't spell country. Okay, a couple of things that we're going to do. You go over here to add chart element. We want axis titles. I need a horizontal. I need a vertical. We need both of these titles. My horizontal title is going to be magnitude. You can make this bigger if you want. Also, if I wanted to make my font bigger, I can make my font bigger. My horizontal or my vertical axis is going to be frequency. Everybody's vertical axis is going to be frequency. Everybody's vertical axis is frequency. I'm going to make this a little bit bigger. Okay. All right. Now, a couple of things that I want you to notice. Notice how my lowest bin, my lowest value is the lowest data value I have. My smallest magnitude earthquake is 4.4. Remember I told you that we can cheat Excel and make it pretty? This is where we're going to make it pretty. I'm going to go up here to my data. This is my smallest value right here. Now, I want to preserve the fact that I have a 4.4 magnitude earthquake. So I'm just going to type 4.4 right here. But I'm going to change this right here to 4. So I know that this is not a true value. I know that this is the real value, but I want my lowest value to be 4 because I want it to be pretty, because we like pretty things, right? You don't have to trick Excel. You don't have to do this. This is just what I like to do. Now, I'm going to double click on this and I'm going to open up. That's not what I wanted to do. Okay. Double click on. Okay. Double clicked on the rectangles and this opens up. So we've got a couple of things happen. If you want to change colors, I've got that there. This does weird things with your glowing and your soft edges and 3D and all of that crazy stuff. This is the one we want, this third one right here. This is where I'm going to decide my bin width. Now, if I already have enough bins, I mean, I could keep this at 0.75 bin width. I don't want 0.75. I want 0.5 bin width. So what I did, so it starts off at auto. So go to bins where it says auto, click on that, go to bin width, and you can change your bin width. So if you did this and you only ended up with 3 bins, you're going to go into your bin width and you're going to make it something smaller so you can get more bins. My bin width is now 0.5. So now I have exactly what I want. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I like 11. So I made my bin width 0.5. Look at this. Isn't this lovely? This looks really lovely, right? Now I do want you to fill this in right here. tell me what bin width you have. Even if you just keep what Excel did, fill in what your bin width is, but ignore all of this. You don't have to do any of that. But do tell me what your bin width is up there. And then this is my histogram. That's all I have. Questions?
I'm seeing gap width and not bin width.
Okay, so double click on this. Let me see here. I double click. Uh-oh. Okay, when I double click on this, we do have you don't have a bin width on yours?
Um,
Because when I do go see here, you don't have a bin width. See here. I'm trying to see. I'm trying to even get gap width on mine. I wonder if it's when I try double clicking on the numbers. Oh, that's why you double clicked on the numbers instead. Try double clicking on the actual rectangles. Because when I double click on the numbers, I get a gap width instead of a bin width. When I double click on the actual rectangles, that's when I get the bin width.
I couldn't get anything with gap width to come up.
How many bins do you have automatically?
Just 3.
Just 3. Okay, I'm trying to see if there's a way to fix that. Maybe you try the numbers. Try double clicking on the numbers. See if that does something different.
It highlights them.
Huh?
It highlights them.
It just highlights them.
Mhm.
Okay, do you know what version of Excel you have? Are you able to tell?
Where would I look? It's just what came when I downloaded it from the school. Would I go to file and look somewhere? Or...
Let's Google this. How to change bin width on histogram and Excel. This is, when all else fails, you Google, right? It says right click on the data series inside the chart. Okay, so go to here, and I don't know if you have a right click. So when I right click, go format. What does it say to say format? Format data series. So I don't have format data series. So when you click on it, so if you right click on the bins, do you have format data series?
Yes. Well, I've series 1 chart area, series 1 data labels, vertical axis, plot area, horizontal axis.
Okay, so I do now. So okay, so I double clicked on, so I right clicked on the bins, and then
Mhm.
I have format data series right here.
Yes.
You have that?
Yes.
Click on that. It should get you right here. Does it get you to bin width now? To bins?
Mhm.
You have it now.
It just everything goes away when I click on it. It just says series 1.1 value 11.
Okay, so let me figure out who's this talking to me. Is this Gwen?
Yes, this is Gwen.
I'm gonna let me do a little bit of searching for this after the class is over.
Okay.
And then I'm gonna write it down right now. Um, bins in Excel. Okay, after class is over, I will look it up, and then maybe I'll post it in the forums in case anyone else is having an issue.
Okay.
Okay,
Good one.
perfect. All right, any other questions other than this weird thing that's going on right now? Okay, let's go to discrete data. Discrete one is the most fun for y'all because this is where you get to be your own creative selves and have a little bit of fun. So once again, I found some imaginary friends, and I asked them how many children they have. It's weird. Imaginary friends have lots of kids. So my imaginary friends have kids, and so that's my discrete data. With discrete data, all the questions are the same. A lot of times discrete data does not have units. Now this is kind of it. They could have units or they could not have units, and I know that's really like it's not real definite for you. Like, but for example, mine does not have units. If I'm counting the number of buttons on 20 shirts in my closet, I'm not going to have units. I know that was a really weird specific thing, but once again, use the definition of discrete to determine, to tell me why you know your data is discrete. Tell me how you got your data. You get to use whatever type of graph you want. Whatever type of graph you want. Go in here, and I don't even care if you reuse one you've already used. Go in here, maybe take a look at what they recommend for you, or just try some different things. Whatever type of graph you want. So you're just trying to choose one that displays your data well. That's all you're doing. So the discrete, be creative, have fun with it, but choose whatever you want. There's no limit. Just make sure you choose something that displays your data well. All right. That's all I have for you. Other than me doing a little bit of Googling and searching and figuring things out, that's all I've got for you. Any questions?
So could we use like a map if we had say countries? Mine was countries and cars produced in each country.
So you
Or
want
would
to see if
that would
you
that
can
be
get
going
that?
overboard? So if you had like a world map,
I don't know how well, I mean, I don't, is this map gonna work? A filled map. I've never tried to do that. If you can make it work, maybe. Yeah.
maybe that's too much.
I mean, you could try it. I've never tried it. So I mean, if you could get it to work, that could be kind of fun, right?
Yeah,
I mean, try it, and if it doesn't work, then just choose something else.
sounds good.
Yeah. Anyone else have questions? Okay, so before I go, really quick, I want to tell you there's not going to be a Zoom class next week, Thursday. I have to do parent-teacher conferences. So Tuesday might be a little bit longer because rather than make you watch the pre-recorded videos, I'm just going to go a little bit longer and do more material on Tuesday. So there will not be a Zoom meeting on Thursday. I will make sure that I'm checking messages frequently and emails and everything, but we have parent-teacher conferences at the high school, so we won't be having a Zoom meeting. I would much rather be here with you than be at parent-teacher conferences, but it's what we do. So just letting you know, I will remind you again on Tuesday. I just thought I'd let you know. All right.
One more quick question.
Yes, of course.
Could dollars be continuous data?
Yes.
They're like
It-
sales.
yes.
Okay.
Perfect. Yes, that's a great idea.
All right.
And
Thanks.
you
I have a
know,
quick question, kind of off topic of that, but for the calculators, can we have, I know you mentioned a TI 84.
Mhm.
Can we have a TI 89?
you can have a TI 89, but Google's going to become your best friend.
Okay.
Um, the TI 89 has it's a little bit older calculator, but and it does more than ours does. So
Okay.
there are a couple of things that are different, so you might need to Google them. Most of the stuff will be pretty much the same. But yeah, it's absolutely okay.
Okay. On like the
Yes,
tests and
exactly.
everything.
Yeah.
Okay.
Anything?
Perfect. Thank you.
No problem. All right. Well, you guys have a good evening and a great weekend. And I will, as soon as I figure out this issue with the bins, I will put something into Excel or into the forums. So have a good night.